The intermediate value is a theorem that plays a big role when you get into calculus. And one of the things that we're going to use it for here is to verify that a solution exists between two numbers. One of the big assumptions that we have to make with the intermediate value theorem is that the function is continuous. If you remember correctly, we talked about in the part where we were solving inequalities that if we knew the sign changed, it had to cross the x-axis. Well, the same thing occurs here. So we're going to assume that we have this continuous polynomial f of x and that we have two real numbers, a and b, so that a is smaller than b. If the function evaluated at a and the function evaluated at b have different signs, so in other words, if one is positive and one is negative or vice versa, then there has to be a place that it crosses the x-axis. So there has to be a c so that the value of the function at that point is 0. That value c is the solution. Graphically, what we are meaning by that is if I have some continuous polynomial drawn here and I choose some a and some b, so that a is smaller than b. Notice that f of a is positive and f of b is negative. This means that somewhere it had to cross that axis, and that value c is going to be a solution to the equation. The same thing is true here. We could have this a and b. A is negative and B is positive. Again, somewhere it has to cross. Now here, notice that it crosses multiple times, but the intermediate value theorem guarantees that there's at least one solution. It guarantees it, but just because the intermediate value theorem doesn't show a different sign doesn't mean there's not a 0. For example, notice here, A is less than B, but f of A is positive and f of B is positive. However, there are still solutions that exist there. So it only tells us that there is one. It doesn't tell us that there is not one. Let's look at an example. We want to show that f of x equals x cubed plus 3x minus 7 has a 0 or a solution between 1 and 2. We're going to do this using the intermediate value theorem. We have a continuous polynomial, which tells us we can use it. We have an a equal to 1 and a b equal to 2. And 1 is less than 2. So all we have to do is show that f of 1 and f of 2 have different signs. When we plug in 1, we get 1 cubed plus 3 times 1 minus 7 gives us 1 plus 3 minus 7, or 4 minus 7, which is negative 3. And when we plug in 2, we get 2 cubed plus 3 times 2 minus 7, which gives us 8 plus 6 minus 7, which gives us 7. So since a is less than b and f of a is negative and f of b is positive, this symbol means there exists a c, and this is such that f of c equals 0. We can also use this and develop it further to approximate a value for this solution. To find the approximation, we're just going to keep getting a and b closer together. So we know that it exists between 1 and 2, so let's go even smaller. Let's now make a 1.4, and let's make b 1.5. When we calculate f of a, and I'll let you do this on your own, we get negative 0.056. And when we calculate f of b, we get 0.875. Notice we still have one negative and one positive. So we know there's a 0 between these two values. So we can get even smaller. Let's make a 1.4 and let's make b 1.45. F of a is going to come out to be negative 0.056, as we already calculated. And now we can calculate f of b at 1.45, which if we calculate that, comes out to be 0.3986. So we still have one negative and one positive. So we know that there has to be a 0 between 1.4 and 1.5, which lets us approximate it at least to a 10th value that the 0 is close to 1.4. And in fact, if we were to graph this, you will find that the solution is 1.406 is the actual 0 of the equation.